S. Chan presents Educational Video Lectures. Difficult concepts made easy. Study anywhere, anytime.
Hello students, we have learned in the previous video what exactly the operational amplifier is. So in this video we will learn about the circuit configuration and the other configuration.
If you want to study this topic in detail, refer to the book by S. Chan Publishing. Link is provided in the description box.
So welcome to the S. Chan Academy. My name is Kanhaiya Jha, and in this video we will learn in details about the circuit of the operational amplifier. We have learned how the pin configuration is generally done. In this video we will learn that what is the input, what is the output, and how we get the oscillation factor. So amplification factor. So this is the ideal operational amplifier. That this is a symbol. Symbol is this, here we can see one leg negative, one leg is positive, and then we are getting the positive leg. So 1 is denoting for the negative, 1 is denoting for the positive, and 2 is denoting for the positive, and 3 is giving us a particular output. So in this particular input and the output, as we compare the circuit, we might have done circuits related to the PN junction diode, transistors, the AND circuit, OR circuit, NOT circuit, NAND circuit, every circuit we have made. And in this circuit we will make a connectivity. Till yet we have not made a connectivity between the input and the output. There is an input and there is an output. There is a basic input is fixed, and according to the particular fixed input we are getting the particular output. So what we generally say is that whatever the nature of the input is fixed, according to that particular fixed input we are getting the particular output. So here we will see that how we are going to connect the input with the output in this particular circuit to make the calculation. So here we can see now the ideal operational amplifier. This we can see leg 1 is negative, leg 2 is positive. Then we have the positive voltage supply and the negative voltage supply, and then we are getting the output. So we conclude here that one leg is there for the negative, 2 leg is for positive, third one is for the output, fourth one is for the voltage supply plus VCC, and the fifth one is for the minus VCC. So if we compare with the power supply, we can see that the 1, 2, then 3 is there, and 4 and 5, they are interconnected to each other. So we can see that here that we are giving the input where the output is coming inside this input. You can see here that the output is coming here. So basically what we can do is we can design the circuit like this also, that if you make the circuit like this, one leg is this, negative to negative, but negative to positive, and this will be the output that we are getting. So when we number it, it is 1, it is 2, it is 3, and here we are getting the output. So we can see that we can interconnect it here like this. Okay, then also we can make the particular calculation. So we can see that how we have given the particular supply. The supply is generally given like this, that we are giving the plus VCC and we are giving the minus VCC at the two particular points, and then we are making the particular calculation. So the plus VCC is given and the minus VCC is given, and then we make the calculation. So here we can see here in detail that this is the the leg 1, this is the leg 2, this is the leg 3. So 1 and 2 are concerned with the input that we give, and the 3 is given to the output that we want, and the 4 and 5 are basically the supply, the positive supply or the negative supply that we need to give. So this is the basic structure. Here we can see, like in transistor, in a very simple example, like in a transistor we give two supply, one at the input and one in the output, and when we compare the the variation between the input and the output. So here also we are giving the two particular supply. Here you can see that one supply and the another supply, and then we keep it grounded, and then we are making the calculation. So this is the very basic structure of the particular operational amplifier, where we study the variation between the input and the output, that how the variation from the input and the output generally happens and how we calculate this particular variation. How we are giving the 1 in the input, 1 in the output, 3 in the 1 and 2 in the input, 3 in the output, and 4 and 5 we are giving this as a particular supply, and from that particular supply we are making the particular calculation. Then we have the characteristics of the ideal op amp as amplifier. Differential input resistance is infinite. So differential input resistance is infinite. So as we have learned that what is the role of the input resistance. So whenever we say that oscillation or amplification, we need in the output to be high. So what we do is that we keep the input low by using a resistance, the input resistance. Okay, when you keep the resistance low, the output become very high. Differential voltage gain is infinite. So voltage gain is at infinity. So when we are getting the gain factor as infinity, then understand that the gain factor is very high. Common mode rejection ratio depends upon the input and the output, can also be calculated as the bandwidth is infinite. We are getting the infinite bandwidth, and the output resistance is 0. So when we are calculating the output resistance is equal to 0 or output resistance is basically negligible, in that case what happens, that the efficiency of the output, we are saying here the voltage gain. So we are calculating the gain factor in the output. So the gain factor always in the output is very high, always in the output. So whatever is coming in the output, the gain factor is very high. The output resistance is 0, output we have discussed. The offset voltage and the current is equal to 0. Then no difference voltage between the inverting and the non-inverting terminals, and no current inputs. So we can study here the different characteristics, how the op amps is generally used, how we are saying that the input resistance is 0 and we are getting the output voltage gain as infinite. How the input resistance 0 is very important when our intention is to calculate a very high and high gain factor. So we will have learned this. Then we have the circuit of the operational amplifier. The circuit of the operational amplifier is, this is the operational amplifier, and this is the leg 1, which is V1, where I1 is equal to 0, and here is a leg 2, which is V2, I2 is equal to 0. Then A is equal to V2 minus V1. Then it will be power supply common, this is the common terminal, and from here we get the particular output. So what we can see here, that this is the A, which is V2 minus V1, and the output will get the gain factor or will get the particular oscillation that has to be done. So one leg and the two leg, we can see that the leg 1 and the leg 2 are in the particular inverting mode, and then we are using the particular power supplies in this, and after using the power supply we are getting the particular output. So very easy to design the particular operation amplifier. If you forget in the exam what the circuit has to be made, okay, then make a very simple thing, make a symbol for a NOT gate, but don't put dot. The 1 and the 2 inputs will work as a minus and plus input, and the output 3 will work as the output. Then we connect the supply here, between the input and the output, and then it will work as a operational amplifier. The circuit is very easy. The circuit generally works for the different modes. Okay, for different modes like differentiator, it will work as a integrator, it will work as a whatever the circuit that we designed to calculate the output, keeping in view that the input resistance has to be very less. In that case only we will get a output infinite voltage gain. Then we have inverting mode configuration. We can see the inverting mode here, that this is the particular leg 1 and this is the leg 2. Leg 2 is grounded and the leg 1 is connected to the RI, R1, R2 connected to the output. So we can see that the R1 is connected to the output and it is the input, and the input is connected to the output with one more particular resistance, which is R2. So this is the inverting closed loop configuration and virtual grounded. So we can see it is a virtual grounded. So how the input and the output are connected with each other, and then we calculate the supply. So this is the inverting mode. Again, inverting mode, that we will invert the particular input. Okay, so we see here that how the circuit is generally made. We see here what is at the leg 1. You see here what is at the leg 2 and how it is connected with the leg 3, and we are calculating the various calculations. So the various registers are generally used in this particular value between the R1, R2 and R3, and using this we are making the particular calculations and all that. So this is what we have to take care when we are talking about the particular operational amplifier in a different mode. Then inverting configuration. We can see in the inverting configuration that how we form the particular register. You can see the register is connected to the input and the output. Here this is the input and the output. Here it is V2 minus V1 connected, and how they have connected. This is a one leg, this is another two leg, and this is a 3 which is connected. So this is V2 minus V1, and this is the particular gain factor which we are calculating between the V2 minus V1. So again you can see that this is connected with a this is 1 and this is 2, and with connected to this. So if we focus yourself, so connection is basically like this. Connection is basically like this. We have break this particular circuit, and after breaking the particular circuit we are studying it, that how 1 is designed, how the leg 2 is designed, and how it is connected with the output with the leg particular 3. So here it is R1, here it is R2, and we can calculate the difference in the voltage V2 minus V1. This is a V1, this is a V2. The difference in the V1 will be calculated, and in the output when we go, we can calculate the particular voltage gain in the particular circuit. We will calculate the voltage gain in the particular circuit, and then we will proceed with the things. So this is R1, this is R2, and this is how this particular gain can be calculated and all. So in summing words, what we have done till yet is the circuit of operation amplifier, how the leg 1, how the leg 2 are generally connected with each other, how we particularly make the calculation, and then how we are calculating inverting mode and how we are calculating in a non-inverting mode. So all these things we have done the pin configuration also in this. Now we'll take a small break, and after the break we'll study further about this operation amplifier.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back, students. Till yet what we have discussed about the operation amplifier, the circuit in the inverting and the non-inverting mode. What we have discussed that how the input are connected, how we are getting the infinite voltage gain, how the particular input resistance has to be less is a very important factor, how we calculate the common mode rejection things. So we'll proceed further in this video. Now we'll discuss about the inverting configuration. We can see here this is the one which is connected to positive, negative, then positive. Then here we can see that here we are not giving the particular supply, we are grounding this particular leg. This is the main difference. We have done the non-inverting. So here we can see that here we are grounding this, then we are connecting one particular resistance from the input to the particular output, that from the input it will go to the particular output, and we are connecting it together. So we can see here that in the earlier circuit we are giving supply to the particular one terminal and the other terminal also, and from the third terminal we will calculating the output. In this particular circuit we are not giving any connectivity to this, we are grounding its leg, and then we are calculating this. So we can see that here that this is the 1, this is 2, this is 3, this is 4, and this is 5, and this is 6. So we can see that here 1, when we can say 1, then 1 here we have indicated that in the 1 what will happen is a V1. Then at two particular point V1 is equal to 0, right. Then at third particular point I1 is equal to V1 by R1, and then it is moving 0. So I2 is equal to I1, which is V1 by R1. So basically what is we required is that here that we say that the I1 current and the I2 current, they are equal to each other, and which is the ratio of the V1 by R1. Then the V0 is equal to 0 minus V1 by R1 into R2. So we'll get the value of the V0. V0 is the output particular voltage. So here we can see that the difference in the particular circuit, that what exactly the difference in the particular circuit is, that how the circuit is generally different from the previous circuits that we have discussed. That in the previous circuit we were giving the particular supply to both the particular inputs. Here we are not giving the supply to both the particular input. We are giving supply to the one particular input and the another one is generally grounded, and then we are connecting the one particular terminal to the particular another terminal of the particular supply. So this is what we are connecting to each other. This is what we generally analyze when they are connected, and we calculate the combined output of this particular operational amplifier. So this is basically when the operational amplifier is generally used in the inverting mode. Then we have the inverting configuration. Inverting configuration is shunt negative feedback. So shunt, basically we all know that it is a small value of the current, is a negative feedback. Closed loop gain depends entirely on the passive components and is independent of the loop amplifier. So the closed loop gain is basically or entirely dependent upon the components, and it is independent of the particular amplifier. So we can make a closed loop gain as accurate as we want, as long as the passive components are accurate. Passive components accurate means that the components that we are using, how they are functioning, what is the error and what is the accuracy in that, how the output is generally evaluated, how we are giving the input resistance, and then with the variation of the input resistance, how we are getting the outputs. These are a very small factor, not in the operational amplifier, but in every particular circuit it matters. So this will generally matter here. Then we have the non-inverting. The non-inverting, we can say that this is 1, this is 2, R1, this is R2, this is connected to output, and this is particularly given as supply current. So this is a non-inverting configuration, series shunt negative feedback. We have discussed in the, we can see the difference in the leg 1 and the leg 2 when we are using the inverting and when we are using the non-inverting. That we have seen that what happens when we were using the inverting and what happens when we were using the non-inverting in the particular circuit. So these are the two particular inverting and non-inverting. In non-inverting, you can see that again the R1 is connected to the output, which is connected to the particular output. This is the V1 and this is the V0, where we calculate the V0. So we have in the non-inverting configuration series shunt negative feedback, it will give the negative feedback. Then we have non-inverting configuration, where we can see that this is the configuration where we see that this is the input 0 volt, then we calculate the V1 and then we calculate V1 by R1, and after that we are calculating from here V1 by R1. So we can see that output voltage is equal to V1 plus V1 by R1 R2 is equal to V1 1 plus R2 by R1. So basically we are using the, of course, network theorems to make the calculations of this. Okay, so we are using this in the input resistance, we are connecting this with a particular resistor, and after making the connectivity we are making the calculations. So we can see that what is the difference between the inverting and the non-inverting amplifier, how we are making changes in the inverting and the non-inverting, how in changes in the input legs and then making changes in the input legs, we are calculating the output in the particular signal. So making changes in the input, we usually calculate what is happening in the particular output. These are the calculations that we can do here. Then we have the voltage follower. Voltage follower, we can see that one leg is connected to the output and this is the voltage follower. As you can see in the circuit that we give one input and this is the output, because the other leg is already connected to the particular output. We can see this one is connected to the output, and from here we give the supply. If you make the circuit like this, you can make it that one is connected to the output and then one is given to the input. So this is for the unity gain buffer or for the follower amplifier, the input follower. We say this as a input follower amplifier, and this is a circuit model that we can use. And here we can see easily that if two legs are there, one is already connected to the output. So whatever the input that we give, we'll give the input at this particular circuit, and from here at this particular circuit, it will follow the particular output. So we have studied that how the particular operation amplifier is used as a input follower. So in this video, we learn the basic circuit of the amplifier, how the input, both the inputs are connected, and depending upon the connection of the input, how we are calculating the particular output. We have discussed that we can make variation in the input, we can make changes, we can give supply to both the particular input voltages, then also we can calculate the output. We can short the particular one input, and then again we can calculate the output. How the resistors are generally connected when we are talking about the input resistors, and we talk about the output resistors, and when we are talking about the infinite voltage gain, then how the connection is analyzed, how it is calculated in inverting mode, how it is studied in a non-inverting mode. So we study all these things in the operation amplifier. This operation amplifier circuit, we have discussed what is the ideal circuit, what is the gate number 1, what is the gate number 2, what is gate number 3, or leg number 1, leg number 2, leg number 3, how the leg numbers are connected to each other, how we make a connectivity from one particular input to the another input, and then we calculate the output in all the concerned cases. So the idea of the operational amplifier is depends upon the uses. As we required, we make the changes. As we make the changes, then it changes its particular name, inverting, non-inverting, comparator, and all that. So this particular video is focusing that how the circuit change can be done, and along with the circuit change, how we can do the calculation, and that calculation leads to the particular output. So we will have the different kinds of output with us when we vary the particular input legs. So this was all about the operation amplifier. In the coming videos, we'll learn more about the amplifiers. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.